Okay, today I'm going to talk about measures of variation. This is section 3.2. Okay, to start, we're going to look at this example that is missing from the PowerPoint because it comes from a different book. But these are two different teams that we're comparing. If we look at just the measures in inches and we were to calculate the mean, median, and mode for team 1, the mean, median, and mode for team 2, they would be the same numbers. So the measure of central tendency would be the same for the two teams. But usually what I do in class is I ask you to pause and take a look and see what is the difference between the two teams. Okay, if you look at the difference between the two teams, team 1, the heights are pretty close together. Team 2, their heights are more spread out. You have the 67-inch and the 84-inch. So this team has more variation. So what section 3.2 talks about, how do we measure that variation? The three main things we talk about in this section that measure the variation are the range, the standard deviation, and the variance. We're not only going to talk about them, but we're also going to talk about how to interpret and understand the results. The round-off rule is different in the PowerPoint than it is in the homework. So again, I would just pay attention to how they say to round in the homework instead of what they say here. The range is the easiest thing to find. All you do is you take the max minus the min. So let's go back to our basketball players. Okay, so for team 1, the range would be 78 inches, the biggest, tallest person, minus 72 inches. Which is going to give us 6 inches. For team 2, the range is going to be 84 minus 67, which is 17 inches. So team 2 has a bigger variation, so the range should be bigger, it's 17, compared to team 1, where they're all kind of the same height, their range is 6 inches. The range only uses the max and mins. So if you have extreme values or outliers, it will definitely be affected by it, so it's called not resistant. Because it only uses the max and the min, it doesn't take any other numbers into account. It only takes those two only. So in that case, we want to cover the other two methods. Let me cover this one first. Here's another example where you find the range. So what you're going to do is you're going to take the maximum speed, which is 55.6, and subtract the smallest speed, and our range is 41.5. Okay, so again, the range only takes the max and the min into account, nothing beyond that. Some other measures of variation that take every single number into account is called the sample standard deviation, and then we'll also talk about the sample variance. As far as notation, in this chapter we're only talking about sample data, so we use S. In chapters 4 on, we'll talk about population data. In that case, they use a small case sigma. Remember we looked at the big case sigma last time when we talked about adding? This is a small case sigma. So in this section, we're only going to be doing sample standard deviation. Okay, so how do we find the sample standard deviation? There is 3 ways. The first way is a formula, which I will show you in another video. This is just a general formula where you take each value, subtract away the mean, and then divide by n minus 1, where n is the sample size. Another formula is called a shortcut formula, and that's this formula down here. And the third way, of course, is your calculator. Okay, so the next video I will show you how to do it the first way, and by calculator. This one I actually don't show you because I think it's silly to show you 3 different ways. A couple things about the standard deviation before we go to that video is the standard deviation measures how much the values deviate away from the mean. So basically what you're doing is you're taking each value and you're subtracting the mean from it. The value of the standard deviation is never negative. It could be 0 if all your values are the same. Like for example, if I go back to the basketball players, let's say we had a team where everybody had exactly the same height. In that case, the standard deviation would be 0, as well as the range and the variance. Okay, the last thing is the more variation you have in the data, the larger the value of the standard deviation will be. The standard deviation increases dramatically if you have more outliers. And the units of the standard deviation should be the same as the units of the original data. So for example, if our units are in inches for the original data, it will be in the same units for the standard deviation. Okay, I have a slide. The next video will cover this, so I'm going to stop here.